So, resource 2, getting the textbook code. So the remainder of this course is going to include quite a bit of code, and there will be code listings that you could copy and paste directly from the text, or you could get the code repository all set up. It's more convenient if you have it all set up for you in one go and all organized. It lets you have all of these packages that we'll be developing in your ROS installation, so that it's available to your ROS installation. So what I encourage you to do is to have this code repository, which is based on the Quigley code repository, on your local installation. Have it set up so that you can simply ROS CD or ROS LS around. You can run the code from the distributed code repository, and then you can develop in parallel with that your own version of the code. So if you are wondering, okay, what happens, I don't know about where, this line, or what should happen, what would this look like if it was correct, then hopefully if you use the version that comes from the robotics book code repository listed here, URL listed here, then you'll be able to check to see if yours is working the way that the my code is working, I guess you could call it. So technically you can just go to this link and download the code repository as a zip file. So that's one option, and I don't really recommend that though, because if you wanted to do some changes to it or edit it, then you wouldn't be able to do so in the Git way. And so this also gives you an opportunity to learn how to use Git and GitHub a little bit to work with software, which is a very important skill to learn. So what I'm going to do in a moment is move over down to resource 2, which is a little crash course in how to get and configure Git and get the robotics book code repository from GitHub, and then get it all working for you. So let's go ahead and do that. So resource 3, installing and configuring Git. This resource will help you install and configure Git on your machine. It assumes you're using Ubuntu or some similar OS. It also takes you through setting up your own Git repository for your ROS packages. So that's sort of what we'll be doing in this little lecture. So first, installing Git. So open up a terminal window, update aptitude, which is the apt or apt-get command that you've been using to install things on Ubuntu. So update it, use it to install Git, check to make sure if it's installed correctly by doing git version, and hopefully it'll respond with some version. 2.26.0 is the current version, but even if it's anything over 2.0, you should be fine. So let's just go to our virtual machine here. Great. I've already got it installed here, but I can do sudo apt update. Just takes a minute. Okay, So now I've done that, and I can do sudo apt install git, but of course I've already installed it, so it's not what I'm going to want right now. Sudo apt install git. It's going to tell me that it's already there. Git is already the newest version. So if you don't have it, it will go ahead and install it for you. Great. So now if I do git version, we see, oh, I actually have 2.17.1 on there, which is different than what I listed there, but that should be totally fine to use. Great. So configuring Git. So Git has some global settings for when you are doing your commits. You will be doing so with a name and an email address. So you can do that. You can set those globally by using git config global user.name and then your name. Git config global user.email, your email. And then these are stored in your user home directory in the file .gitconfig. So if you want to change them later, you can do that and save the file. It's a hidden file, .gitconfig, but it's there. Dot files start with a period, and they are hidden files in your system. Okay, so then setting up github.com. So go ahead and go to this link, github.com/join. You can sign up, get your account set up. It's pretty easy to do, pretty straightforward. It's free. There are different versions. There is an education version where you can try to get a pro account for free. So you can do private repositories as well. I encourage you to look into that. But you can first just join with whichever email address. It doesn't matter. It doesn't have to be edu, and then you can later verify that your edu email address is valid, and they'll let you have some perks for free. So I will recommend, so every time you try to submit a push to your GitHub repository, it's going to ask you to enter your GitHub username and password. And that repository, hopefully you'll be interacting with it, frequently, at least the one that you're going to make for yourself. And it can be somewhat cumbersome to do that. So one way to avoid that is to use SSH. And there's this GitHub article, the URL there is a shortened URL that will get you to the setup instructions for getting an SSH connection to GitHub, so you don't have to enter your username and password every time. It's nice. It's not that hard to set up. I'd recommend it. It's a few steps, but it's really not that bad. Okay, create your own package repository. You want a repository for your ROS repository, so you want a GitHub repository. Create a new one on GitHub. So these are instructions for creating new repositories. It's pretty straightforward, but I'll go ahead and make one here. So we're going to now create our own package repository on GitHub. I'm going to create a new repository. So if I do this little plus sign, let me do a new repository, and let's call it example. Okay. I'm going to make mine private. I don't think you can do this unless you have a pro account, but if you do, if you use your edu address, you can get a pro account, so you can make private repositories. Initialize this repository with a README. It depends. So if I'm creating a brand new repository for the first time, I'll usually use this initialize it with a README. If you don't want it to put in a README file automatically, then that's totally fine, especially if you already started one on your local machine. So depends for me. Usually I'll initialize it with the README because I haven't done anything locally yet. You can add a Git Ignore file. So the .git ignore file, what it does is it has a list of file extensions to ignore when you're using Git. Git will keep track of all files that are not listed in the .git ignore. I will typically, edit it for myself. I'll add like the hidden Mac OS files to the Git Ignore because it wants to track them otherwise. But there's a default Git Ignore that comes for different languages. So I noticed that there is one for ROS, so we'll include it because we're going to use it as a ROS repository. You can add a license here. There are several options. Apache 2.0 is what I chose to do with my repository. It's pretty permissive. You can look at the info on it. You don't have to add a license if you don't want to. Create repository. Now I've got it. One of the nice things about having the README be a part of your creation of the repository is that it already starts off with a little page here. So readme.md is .markdown, okay? So markdown files are like shorthand HTML, and there are all kinds of guides on like GitHub flavored markdown. The README files are written in GitHub flavored markdown. You can edit it even on here if you'd like. So if I go to this file, I can edit it in the browser. This is not typical. We're not typically going to be editing our files in the browser, but we can. I can say, this is an example README. And I could do, here's a subsection. Here's a link. And this is the URL link. So I could just do it to like HTTP, my website. And then I would commit the changes. I'll say added some good stuff, but it should be descriptive, right? Commit changes, and here's what the front, or here's what the README looks like when it's rendered. If I go back to my base of my repository, the README file gets rendered here in pretty printing, and then the URL shows up here. Here's a link, subsection, section. So this README stuff is pretty nice. The license file was in there automatically. Git Ignore is in there automatically. Yeah, so we've created a GitHub repository. And now we would like to clone it down to our local machine. Now we want to go to our terminal window and go to a place that we'd like to bring the repository down into. Now, you have to be inside a workspace for this to be a ROS thing, right? So I've got in code, I've got ROS workspace 01 is a ROS workspace. And if I cd to source, I've got the robotics book code suite package, which we made together. And now I'm going to also bring this example repository in here, okay? So in a workspace's source file is where we're going to want to do it. And then we're going to want to use git clone, and I can make this a little bigger. Yeah. Git clone. And we're going to want to clone the URL that we can copy from here. So if we want to clone this, there's a nice big green button that says clone or download. So clone, copy that URL. So if you're using SSH, you actually have to use this URL. So it toggles between the two. I am using SSH, so I have to copy this one. So git clone. And now, if I ls, I've got example as a directory. So I can cd to example. And there we go. We've got a local copy. Notice it doesn't list git ignore, but it's there. If we wanted to do subl.git ignore, which opens a Sublime text for an editor. Here's the git ignore that came for Ross. So that was kind of nice. There are some things that you probably don't want to back up every time, or you don't want to keep track of in terms of your Git repository, so it'll automatically ignore these files. Okay, so you aren't going to keep track of your logs, for instance, or the build. So great. So we've got a repository. We can do stuff here. Like I could edit the README. Okay, the README, we edited it in the online interface, but I can say here's a subsection I added locally. Okay, save it. Now we're still sort of following here. So we can create a new package, which I recommend you do. This is what you're going to do in this repository. I'm just going to show you how to do a quick git commit and push it so that you can do that when you get your package as well going. So what I just typed in was git status. Git status is going to tell you what's going on. It doesn't do anything other than report things back to you. So it says that changes not staged for commit are in the readme.md. I could do a git diff readme.md, and it would list out the things that are changed in the file. So we've got, I added in, that's the green, I added in 4 lines with this material. So that tells you kind of what is changed. And what I can do then is I can say, okay, I want to commit that. So first you have to stage it for commit. So you have to say, okay, part of this commit to the repository is that is the README file. Okay, so git add file name. If you want to just do everything, so we only changed one file, but if you want to add everything to your to be staged for a commit, you can do this. So you might ask, why do you have to add before you commit? Well, it's because you're going to want to, you might change multiple things in multiple files, and then you might want to commit them in different commits. You might want to change one in one commit, change another in another commit. So you can stage things for commit. Now, if I say git status, like with using git add, so if I do git status now, it tells me, oh, okay, changes to be committed, modified readme.md. So it's ready to go. So now if I do git commit, then I use the, if you don't use the M option, you have to, it opens up in a text editor for your commit message. But you can do it inline here. I usually just do it inline here. So git commit, now here's the message in quotes. So I'll just say added local subsection. Enter, and it committed. So now, oops, git status tells me, okay, your branch is ahead of origin master by 1 commit. So which means that the repository that's online, the GitHub repository, is behind. It doesn't yet have what I've committed. So the local repository has the change, but the remote repository doesn't. So I can push it up to the globe or to the remote repository on GitHub with git push. And there we go. So now GitHub should have my change. So if I go back to the GitHub file, so it was the README that changed. So this is going to change when I refresh. Here's a subsection I added locally. So it got my change. And it has here as the commit added local subsection, the one that I just did. So there's a lot to Git and to GitHub, but it's really not too bad to do pretty basic things like have a repository, git add, push, commit, all that. We've got a repository that we've created, a new one, and we've managed to bring it into our local Ubuntu installation with Git, edit it, push it back up, add it, commit it, push it back up. So we've done all that, which is really like all of the basic mechanics of using Git. And the only other major thing that we'll have to learn here is how to fork a repository, which isn't that much different. So the idea though is that we can go and get the book repository, the code repository for this book, and we'll fork it. Okay, so forking a repository is saying, okay, I want my own copy of it on my GitHub account, and I'm going to then edit it and do commits to it and changes that I don't want. I mean, that won't go into the primary repository. So they won't go to my GitHub repository. They'll go to your copy of it. Now, you might end up doing something with the code that I will want to incorporate into my code. So if you make a change that's like that, there's a thing called a pull request that you can make from your fork to my original repository, and I could accept the changes that you've made. So this is one of the foundational ways that code is worked on collaboratively using GitHub. Another option is to add somebody. If you're working with a tight group of people together on the same project, you would add people as collaborators on the same repository, and then they could directly push to the repository. Now, I'm not going to give you guys all access to my my repository as collaborators. I think it would just create a big mess, so we'll do the forking option. You can do this with your, you can create your own repository. You could just clone it and do all that, but I think it's nice to use the fork feature, and this feature is really nice and is used across the Git ecosystem. So I'll show you guys how to do that. So we're going to want to clone the repository to the Linux box. So I'll open up the virtual machine, and once again we want to find a place that we would like this to live. So we want it to be in a workspace in the source directory. Now, because this is where ROS packages will be written, right, in the workspace source directory. So I've already got a copy of the robotics book code here. So I'm going to just go to a different location just for fun. I'm going to make a directory called ROS workspace 2, and I'll cd into it. Oops. And there's nothing here right now. I'll make another directory, source, okay, and I'll cd down into source. And this is where I'd like my copy of the robotics code repository to show up. So if I go to the my GitHub, which you'll also go to my GitHub, I've got this robotics book code directory. So the URL will take you here, and you want your own copy of this, okay? And it has some instructions here on how to do this. So create a ROS workspace with a source directory, download and unzip or clone this repository to the source directory. So this is one way to do this. I'm going to recommend, though, instead of doing that we fork this. So we'll go up here to fork, and I can't fork it from within the same GitHub account. So let's say that I forked it. So you have to go through the instructions to fork it. It's very self-explanatory. Then you'll have your own version of this. It'll look just like this, but instead of it saying Rico Piccone here, it'll say, Angela Bassett or whatever. I can't think of like random celebrity names off the top of my head very well. That was apparently the one that came up. Obviously, thank you. Yeah, so robotics book code, it'll say your name and then robotics book code. So now you've got your own fork of my repository. Then once you've forked it, you'll just do this command, which is git clone. I'm going to use this is if you're using HTTPS, so if you haven't set up your SSH, I'm going to clone it using SSH because that's what I have set up. And I'll use git clone and the URL, and boom, it came. So if I ls, I've now got the robotics book code repository in my workspace source directory. So now if I cd into this, I've got some different directories. So this is organized into chapter, the first, like the short, like an abbreviated version of the title of the chapter. So for this chapter that we're in, chapter 7, it's Rico topics. I put Rico before everything so that it wouldn't step in on the namespace of other things. And I think that you guys might consider putting, making your own versions with, when you write your own code, putting your first name or something at the beginning, just so that they don't step on your namespace, so that they stay separate. But you don't have to. It was just a thought. Okay, so this package, Rico topics, is for this chapter 7. There's the package tree. It looks pretty much normal. There's package.xml. We could look at that and see. Here's what it is. Website. Here are the depend tags, and that's as we would expect a package XML to look like. You can cd into its source directory, which is going to have the Python code in it. So we see these different Python files here. So if I do Sublime Text on this directory, it'll open up this, so I can look at the different Python files in here. And this is what we're going to write in chapter 7. Okay, these are the different Py files we're going to write here. So yeah, good. So all this code's here. Now we just need to make it available to our ROS system. I am not going to do that directly in that workspace because I already have a workspace in parallel that has all these packages, so it would freak out if I did that. So what I'll do is I'll go into my ROS Workspace 1, where I've already downloaded into source, I've already cloned into source my robotics book code repository. So now let's say I was to change something in there, which, okay, let's say I'll do that. So I'll cd into robotics book code. I'll look at the, so again, we got a README file. I could also go into one of these packages, so Rico topics and source, and then I could open up so I could open up Sublime Text editor with all of these Python files here, and topic publisher, for instance. I actually edited this. I took out some white space like a few minutes before I started this lecture. So what I might want to do is actually pull down those changes. Okay, so let's do that. So say you guys are like, okay, I'm going to start working on this chapter. I want the latest version of what the robotics book code's doing. So you navigate to it, and you do maybe git status, make sure, okay, I haven't edited anything here. I did the editing actually on the Mac side of my machine. So if I had edited that, I could have come up with a merge conflict pretty easily. But so what I wanted to see is anything in the GitHub repository that I don't have here. So do a git pull, and sure enough, I had a change, and it looks like I added a Git Ignore file, or no, I added a line to a Git Ignore file. I had changed some lines in topic publisher. So what I could do now is I could say, okay, I wonder what the difference is. You could use Git Diff to do that. I'm just going to look at this file because this is the one of the ones that got changed. Topic publisher, and notice that a bunch of the white space just disappeared. So Sublime Text just realized that this file was different than the version that I was just looking at, so it just changed it, and a bunch of the white space is gone now. So now that there's been a change to this code, I want to remake the workspace so that all of the latest package information is available to ROS. So now I can do catkin make, and it will go ahead and do its making of each package. And this takes a few minutes. It'll go through all of the subdirectories. So your packages don't have to be written at the top level of the workspace source directory. They can be subdirectories. So like we've got the robotics book code here, not just a straight package. So the packages are actually subdirectories of robotics book code. That's okay as long as they have their usual CMake lists and package.xml. ROS will find it when you do catkin make. So you might wonder, are these showing up globally for me? So if I cd to my home directory, I can simply do ROS cd, and now I want to change directories. I want to go into that Rico topics directory and see that it's recognized as a package that's available. So I could also see what other ones are in this that are listed that are starting with Rico. There's the chapter for the topics chapter, the package associated with the topics chapter, the package associated with services, actions, and then wandering turtlebot. So those are the next few chapters. So I could choose topics, and now I'm in the Rico topics package. Okay, so this sort of gets you set up to use this code, and now you have a fork of it. You've got it locally, you've got it available to your ROS system. So now as you work through, you'll be able to use those. You'll be able to fire up these nodes if you want, or they'll be available to you. But hopefully right alongside, so I would say maybe in your workspace you have robotics book code, and then I put example here, but you could say like my ROS packages repository. Maybe you want to just have one repository for all of your ROS packages. You could do one for each package. You could do a repository for each package. It's probably the better way to organize it. But for now, you might want to just say, okay, I'm going to do multiple in the same repository. So my ROS repositories could be in what you called your repository. And then you could make your own packages in there. You can keep it synchronized with GitHub. And you could also run my code from the robotics book code directory as well to test it out and see if it's working the same as yours. So that's pretty much that.